So again, with confidence intervals, I'm making an estimation. So think of it this way. I have the population. Let's say mean is what I'm interested in. The mean is unknown, and I take a sample and get a sample mean of 50K. Say 50,000. Let's say we're talking about salary. My estimate for the population mean is 50K, but it could be as high as 52K or as low as 48K with 95% confidence. So basically the end result of this problem is I can be 95% confident that the population salary, let's say, average salary, is between 48K and 52K. I took my sample mean 50K and the calculated margin of error was 2K. But again, I'll show you how to do the margin of error. Okay, so in the chapter you saw that there were problems where you know sigma. That's pretty rare, so I'm going to skip that section. It's pretty easy to just to do those type of problems in Megastat if that were to come about. But I'm going to mainly focus on the most common, which is where you don't know the population standard deviation, but you do know the sample standard deviation, which is typical. If you're getting a sample, you're going to have the sample mean and sample standard deviation. Not as common to have a population sigma known, population standard deviation known, without knowing the population mean. Okay, and then we'll cover confidence intervals for a proportion, but we're going to start with confidence intervals for the population mean. So let's say we're interested in a variable monthly cell phone minutes, and a simple random sample with 35 people had a mean of 553.4 minutes, and the sample standard deviation was 115.4 minutes. I want to know where the population would fall with 95% confidence. So again, I'm choosing the confidence level here. That's something that can be worked with. You know, maybe I change it to 90% depending on the results, or 99. Okay, here's what's going into it. Megastat is going to do this for you, but I just kind of wanted to show you that we have the sample standard deviation, so that's going to measure the variability. The sample size, as you saw before, sample size and variability are part of it. And this t value from the t distribution is going to represent my confidence level. Basically, there's a certain level of confidence, a probability associated with that, and then a t-score. You don't really have to know too much about that. I just wanted to show that confidence, variability, and sample size are going to be part of this whole side, which is the margin of error. And I add and subtract that margin of error to the sample mean. Okay, I'm using the t-distribution, which is more conservative than the z. The z is when we have a normal distribution. So t is a little bit more conservative. As the sample size increases, the t-distribution curve approaches a normal distribution curve, however. But we're just going to use the t-distribution, and you'll see in Megastat that there's just an option to click on either t or z. So for these problems, we're always just going to use t, the more conservative, because we don't have population standard deviation. Instead, we have the sample standard deviation. So here it is in Megastat. If you go to add-ins, Megastat, you'll see confidence intervals and sample size, and you'll just click on the confidence interval -mean tab. You put in the mean. Okay, so we found 553.4 cell phone minutes, and then the standard deviation was 115.4. That was with a sample size of 36, and the confidence level we chose was 95%. And you can see here, this is where I would select T. You're always going to select T. The only time you would select Z is if you had the population standard deviation, which, like I said, is pretty rare. Okay, and then when you hit OK, this is the end result. Basically, it gives you a margin of error, which they call half width here. That 39 minutes is the half width or margin of error that is being added and subtracted to the mean of 553 to give you the confidence interval. So I can be 95% confident that the population mean falls between 514 minutes and 592 minutes. Okay, so we can say that the sample mean has a 95% chance of being within 39 minutes of the true value of mu, the population mean. In other words, 95 out of 100 samples will have a sample mean within 39 minutes of the population mean. But what's more commonly, how we normally say this is basically we're 95% confident that the true mean, or population mean, is between 553.4 minutes minus the margin of error and 553 minutes plus the margin of error. That's called the confidence interval. So basically, I can be 95% confident that the population average number of cell phone minutes is between 514.4 and 592.4. Okay, let's say we had this problem. I asked 12 students how much rent they pay and get sample mean and standard deviation of 812.50 and 78.41 respectively. What is the 99% confidence interval for the population mean? Okay, so let's stop there and I'll go to Megastep.